When man resolved to imitate walking, he invented the wheel, thereby becoming the first engineers in the world. Engineering is an art, and it takes an artistic engineer to find novel solutions to challenging problems. Good design is obvious, but great design is manufactured with ease. Welcome one and all to the technical sessions of the 11th Engineers Conclave by IMAE. This venue shall host a most prominent and much discussed theme, defense manufacturing technologies. As mentioned earlier, manufacturability brings life to a design. With more focus on Atmanirbharta and Viksit Bharat, the advancements in the manufacturing sector shall pave the way to achieve these dreams for the nation. Defense manufacturing technologies shall strive to focus on deliberating various state-of-the-art researches undertaken across the country. The architect of this theme, who has beautifully created the various sessions, is none other than our very own Shri Jitendra J. Jadhav, Director General ADA and former Director CSIR NA. Shri J. Jadhav, with an experience of over 33 years in design and development of fighter and civil transport aircraft, flying trainers and its associated electronics and control systems, was instrumental in steering the initial operation clearance of LCA Tejas and its induction into the Indian Air Force. He steered the weaponization of Tejas and helped in development of aerospace industrial base in the country. He is a proud recipient of many eminent awards, including DRDL Scientist of the Year Award, DRDL Agni Award for Self-Reliance, DRDL Performance Excellence Award, and many more awards. I take great pleasure to welcome you today, sir.
Further, I would like to say that I am going to say about the theme is the transcending, slightly we have modified. It was set as military wing aircraft. We have just added transcending the fixed aircraft segment because my colleague will be talking about the rotary wing and there will be a speaker from NIL to talk about the civil version of the aircrafts. So it will be transcending the fixed wing segment of military aircraft. And I firmly believe that it is not only HAL, it is the complete ecosystem what has been developed in India that is helping us now slowly and steadily moving towards transcending this aircraft segment in India. And unlike most of us have expected, we are moving forward and we are moving forward steadily. I would like to the presentation outline will be made in this format, a brief history of the Indian aerospace industry. This is a slight introduction about how the aerospace industry has evolved in the world and what are the milestones which we have achieved during this journey of Indian aerospace industry till today, and what are the technologies what we have gained in this process. We will like to recapitulate the technologies what is in store for us and what are the challenges. Dr. Tagis has said, what are the challenges what we are facing today and what are the initiatives we have taken, especially I can speak about HAL what we have taken, initiatives what we have taken and what is the ecosystems, basically with respect to the LCA program what we have done, what is the ecosystem right now what has been created and a brief like what Dr. Tagis has said, what is the Indian budget and what is the industry performance, where are the gaps which the other industries can come out and what is the way forward. This is what I would like to present in this 20 minutes presentation. If I would say that man has got an intention to fly, a strong desire to fly from the very beginning onwards, from very beginning existence onwards. If you go to our Puranas, our stories, old stories everywhere, we have got all desire to fly. And the flying has happened in between through hot air balloons, different stages. But the real flying which has happened was in 1903, December 17, when Oliver Wright and Wilbur Wright has flown the first mechanized aircraft. That was the first stage of the aerospace industry in the world. But now the curious thing is that after he has flown the aircraft, the first order for this aircraft has not come from a civil aircraft field. The first order for this has come from a military aircraft. So if you see the specification of that, the first military aircraft, at least 1 hour with a pilot and a passenger at an average speed of 40 miles, 65 kilometers per hour for 120 miles. So if you go back to the history, this can be said as the first ASQR for an aircraft. This is the first ASQR for an aircraft which has been done, and somewhere in 1909 July, this aircraft was delivered to US Army. It was given to US Army as a surveillance aircraft. So from 1909, immediately after that, 2 world wars followed. And in the 2 world wars, the First World War and Second World War, and this is the time when the aircraft technology has really taken off, because man's intention was to save himself and in that process to destroy others. So this is one of the basic means of mass destruction, but however, the technology developed was also used for humankind. So this particular process from 1909 till today, the technology has evolved, and most of the technologies which have been evolved during this aerospace industry has been utilized for developing mankind also. So India also did not fall behind much in this process of developing aerospace industry. Indian aerospace industry, if you see, the beginning of this Indian aerospace industry was from this land, the piece of land, which was given to Sir Walchand Hirachand by Mysore Maharaja in 12/1/1940. So, Indian aerospace industry taken off from this barren land. The next slide, if you see, you will be really astonished. 1940 July, this piece of land was given, where there was no project management, there was no what I would say Internet of Things. In July 1941, the first aircraft has flown from. It was an overhauled aircraft. The first aircraft was flown from this land. So this was the kind of initiative which has been taken by Sir Walchand Hirachand and his team for developing this aircraft. And this was the beginning of the Indian aerospace industry. And that I would say, this is the first milestone of Indian aerospace industry. Then what has happened, 1941 to 1970, there were various phases of development of Indian aerospace industry, except SP2, and if I say the G110 glider, these two are developed by HAL. The remaining aircrafts are basically done with collaboration from other countries. The 2 aircrafts which I have missed, one is Kiran, that was uninternational. Second one is Marut, which is intentional, for about that I will say later. Kiran was a miss for me. And then from 1970 to 2000, this era was basically an era of technology transfer. This is the time when the armed forces demand to accelerate the induction of the aircraft and modernize their fleet. So you're seeing the need of the hour. Developing a full-fledged military aircraft in India would take considerable time. So it was decided to go with technology transfer from the Russian side as well as from the Western side, with which Indian fleet strength grew immensely and fighting capability grew. But there was a slight lack which has happened in our own indigenous design capability. This is the period where the aerospace design capability in India has slightly come down. That is this phase, 1970 to 2000. But in 1983, the LCA program started. But before that, I have told about the milestones in the Indian aerospace industry. The first milestone, what I have said, was 1941, when the first Harlow aircraft flew from the Bangalore facilities. The second one was the first, I would say it was a supersonic capable aircraft, Marut, in 1961, which is produced by HAL, by a team of invited German scientists, Dr. Tank, and a selected team from ARDC. They have produced an aircraft which was capable of achieving supersonic. What I would say, this was the first supersonic capable aircraft of Asia. And you can also see that the first prototype flight was in 1961, and in 3 years' time, because there was a pressing need, this aircraft was inducted to service. And if you could visit the Deutsche Museum in Munich, a model of, not modern, a Marut aircraft is kept there. So that is the importance of the Marut aircraft, and this I would say was the second milestone. Even though I have said it is the second milestone because after the 1941, this is the second milestone of Indian aerospace industry. Now it comes at the day which is etched in golden letters in Indian aerospace history, 4th January 2001. Nobody can forget about that day. The first LCA has taken off to the skies. And I can see a proud Jadavs are sitting here for this, who was also a part of this mission. And this, with this LCA production, we have achieved a lot of technologies what has coming into the aircraft. Though I have said it here, multi-node radar, counter measurement system, all these aircraft technologies are achieved. I have done a summary of these technologies what we have achieved in subsequent slides. But this in 2013, and it was given IOC, and 2019 it was given FOC, and right now we have got 37 aircraft in the Indian service. Now finally, another major milestone was the Mark 1A flight. The Mark 1A is a different aircraft even from Mark 1, and with very advanced technology what has been given onto this aircraft. So on last March 28, 2024, the first flight of Mark 1A has taken place. If you really see the technologies what has gone into it, and also the complete synergy between all the design and manufacturing organizations which has worked for this program, this is again another important date which has to be kept in the history of Indian aviation. Now if you see this during the last, what I would say from Marut days onwards, 1960 onwards, where actually the indigenous fighter development program has commenced, the different technologies what we have gained. Really speaking, we have mastered the airframe design and analysis. We are capable of doing any kind of airframe design and analysis. The second one is the composite structure. Here, till LCA started manufacturing, we never had the opportunity of machining composite structure or using the composite structure for producing an aircraft. And this is the first time, and now after 20 years, we have mastered composite manufacturing. And we are imparting this technology to the private industries also. The third one was mission computer. For any aircraft, fighter aircraft mission, this is one technology which is essential. Because this is the essential technology which is required for the weaponizing and all the operational of a modern aircraft. With LCA and slightly before that Jaguar aircraft, now India, along with other design organizations, we have mastered the mission computer. Flight control, DFCC. This HAL and not only HAL, ADA, ADE and Bell and other organizations have acquired this technology in spite of the US sanctions post 1998 Pokhran blast. And this was a major achievement. Now with DFCC, which has been proven in the Mark 1A flight, we can say that this is behind us and we are poised for further growth. Integration of new weapons and systems with MC and DFCC, which has been proven. HAL does not have to depend on any, not only HAL, India does not have to depend on any foreign countries for integration of our weapons. Uttar Pradesh, it is on the cusp of integration and flight testing, and we already have the ASA radar which is flying on the LCA. Software defined radio, which is again another technology. During this process we have acquired. The different design organizations have acquired RW1 and CAT, the CAT internet and transporter. This is the additional technologies, major technologies which we have achieved during the LCA Mark 1A flight. That is why I have said this is again another milestone in India's aviation history. And along with that, other two important aspects of aviation is the test rig design and the flight test instrumentation, which is essential for all aerospace development. And we have, with this, we have developed a complete repository of aircraft testing within India. Now, if you could see this, the technologies which are kept in the blue we are completely developed, we are on our own. That means all these technologies and where we have kept in the pink color, power plant, materials, avionics and to some extent electrical, seat and armament, we are still dependent on foreign OEMs. The first thing is raw material and the raw materials for airframe. Raw materials is more of a techno-commercial issue because our demands are less and the cost of development is high. So by pulling up, I think it is possible by development of raw materials. Now, Minani and other organizations have come forward, and for the next batches of LCA Mark 1A, more than 60% of the raw materials will be made in India. But this is a niche technology which we need to develop. The second biggest challenge, which Dr. Tyagi during his introductory speech, which has said is power plant. The news are in the media regarding the delays of supply for engine for LCA Mark 1A. Yes, partially it is true, but the development of engine is always a priority for India, and GTI is already developing this program, but we have some way to go. And this is a technology because there are two major technologies which are involved in the development of engine. One is the manufacturing technology, other one is its metallurgy. The manufacturing technology with the TOT program to somewhat we have achieved, but metallurgy we have yet to go. And this is one area, another focus area which we need to work together. Ejection seat, yes, it is a proprietary of one of the companies in the world which they have spent years and years of technology and research behind that. So it is not that easy to get the technology, but we are on talk with Martin Baker to start their plant in India. And finally, there are still some more avionics capabilities which have been left for development within India to make it fully Atmanirbhar. Now, what we would see with respect to the future platforms, these are some of the technologies. I am not talking about the other technologies. These are some of the technologies, the cutting-edge technologies which we are envisaging to develop and we have to develop. The first one is here, what is mentioned is combat air teaming systems, which is a team of manned and unmanned aircraft. And with this, what happens is you have got a multiple pronged weapons which is in the aircraft, which is in the air to attack the enemy sites. We need not cross the border. This concept is already on the design stages, and we are accelerating it for this production. Satellite space communication link. This is, everyone knows, this is an area which intense research is going on. Direct energy weapons. This is a slightly debated topic, but direct energy weapons are the one where it is not any kind of projectiles are used. This is like a laser guided energy weapons for which advanced combat technologies are used. Autonomous technology, more of AI into weaponing. This is one area. Another future research is going on. Today morning, we had a discussion on how the sustenance can happen in the aerospace industry. The future, fuel cell for airborne, especially using hydrogen in aircraft applications. This is another area where the research needs to go on. AI-based technologies, which now we have stepped into this, but we need to accelerate on AI-based technology. With all this, the cyber attack protection, that is another major area. It's a major threat for aerospace industry. Pulse electrothermal de-icing system. This again another energy saving methodology for which the de-icing consumes a lot of energy, and with electric de-icing, this technology has already in the primitive stage, but again another technology which will be there in the technology denial stage from the Western countries, another investment which is required. Electric braking. Now, again, about to avoid many of the braking systems, this is again another conceptual stage which we need to take it. These are all the technology where the new startups and institutes can work together with industries to push us forward into the era of the latest technology. During this process,
Yeah, Krishnan, you have another 5 minutes to make your important.
Yes, okay. During this process, we have created a complete system for interaction with the vendors and suppliers for development of and to be a part of this our aerospace programs. This is an interactive portals which are available for vendors can access, and these are the impetus what we have taken for indigenizations, which is available with HL websites. We can go through this, and these are the handholding with vendors, which is again we are continuously doing. IDEX is another platform where HL and other major design organizations of government design organizations are working, and HL and BL are the pioneers in IDEX platforms. We have given major projects for some of the IDEX vendors, and it is getting the fruits now. And with respect to LCA program, regarding supply chain and the design development, this is the ecosystems what we have developed. We have got more than, if you say 140 design, I mean it is a minor or minor design collaborations which has happened. Manufacturing companies 66 and plus another 240 manufacturing companies which have been involved in this, and overseas suppliers are 82. So if you compare, we have got a major manufacturing ecosystem within India for the Tejas program. And this is a map, pan-India. So it is spread all over India for the program. And if you see this, this is the technology which we have been sourcing from major fuselages. The front fuselage from DTL, and the center fuselage from BEM, and rear fuselage from Alpha, and being the most complicated from LRD. Dr. Zari sir has said, I have plotted only up to 2024, and it has gone up to 6.25. This is the Indian budget what is available. And but if you see the defense public sector undertakings is 57%, but if you see the defense private companies, 21%. So there is a major chunk is available, and this is the way the public-private partnership which this area will bring, and so that this particular portion, the public portion, will be more focused towards design and development. This is the current ecosystem which is slightly complicated. We would like to transform this ecosystem into a more streamlined one, a product-based ecosystem. Today morning, we had a beautiful session, and some of the points actually I had not taken before from that discussion, but before this itself it has come to our mind. These are the key drivers for our future development. There are two actions. One is this, I would like to spend a little bit time on what are the driving forces on this. The first driving forces today we have said is the cutting edge technology. Nowadays, the technology is moving at a very rapid pace. From the metal cutting to additive manufacturing, digital twins, more of digital field is coming, and with this cutting edge technology, we need to improve our own manufacturing process. With this, now the workforce need to be moved from skill based to knowledge based, and the developmental process, the industrial development process, need to substantiate the skill based, the knowledge based workforce, and for the new cutting edge technology, and collaborate and acquiring through the OEMs, which we cannot have our own technology fully developed within India because of various reasons. So a collaboration model with OEMs is what is always better, especially for the engine. Now we are trying for a collaborative model with GE, and also there are other areas starting from even fasteners. When companies like Boeing, Airbus and all, they are trying a collaborative model with even for fasteners. So these are the areas, identify the niche area, collaborate model with OEMs. And these are the way forward for developing technologies, what I would feel. First one is the cross-sectional innovation. The cross-sectional innovation means we need not look only at the aerospace companies for development. We can mold, especially automotive sector and other infrastructure, for coming into aerospace mode. The perfect example what I can give is MRF. India, asset together Indian Armed Forces were importing the tires from London. But with the basic experience of automotive tire manufacturing, now the complete gamut of tire manufacturing in India is being shifted to MRF. This is one area where the collaborative method with respect to other areas of manufacturing can propel the aerospace industry. The other area is today during the discussions which has come up, the data exchange, where there are different organizations are working on various the same program. So data exchange among the organizations which would help on what is available in India, and this seamless integration of this data would help us move forward. And other one is the innovation policy, which I really would see that an innovation policy is required for us. Innovation policies always say that when we do a mistake, learn from the mistake and move ahead. Don't punish the mistake, learn from the mistake and move ahead. If you don't do that, the industry, the nation needs a specific innovation policy for the startups and other organizations to come up so that we can move forward. And other one which I would like to express is the long-term business partnership model. We cannot develop a vendor and throw him out once it is possible. So the business partnership has to be a long-term, and aerospace model is actually requires a longer gestation period. And with this longer gestation period, the other organizations like SIGMI, ASSOCHAM and CRT, all these organizations can work with the vendors, making them understand and having a long-term partnership model with the design organizations as well as industry. And finally, this is what we would like to be. Now, the academia, industry and R&D centers, the collaboration is limited. Especially between industry and academia, we need to do a lot of collaboration. And finally, this is what we should achieve for the progress of the country. We should have a major chunk which is falling in the industry, academia and R&D center. The joint R&D institutes will propel the growth of aerospace industry because it is more of a technology-driven growth. For people who have not seen the first aircraft, LCA 5034 taking off, this is a major event for the Indian aerospace industry. The first Mark 1 aircraft on the skies on 28th of March 2024. Surprise, proud moment for all of us. Thank you.
Thank you, sir. Good afternoon to all. I think from morning we are totally immersed in different scenarios, and probably my slides will look very different to you. So please give me some time to explain these things. So my topic is basically the civil aeronautics at CSR NAL. We are not using the word civil aviation. There is a minor difference. Aviation we are interpreting as operation of the aircrafts which are taken up by the airlines. But aeronautics at NAL, what we mean is the design development by NAL, flight testing by NAL, certification by NAL. So this whole gamut is being covered in the word aeronautics here. So you can see the small aircraft to the bottommost picture on the 90-seater, which the session chair also mentioned in his opening remarks. So my presentation is structured in basically 4 sub-bullets. I will give you introduction to 3 or 4 civil aircraft programs which we have taken up at NL, and then what have been the achievements and where we got held up, how it has been taken up in the next project or in the same project, and then there are a few possible solutions which from our point of view we would like to propose and submit to the session. So brief one slide introduction to NEL. At NEL is basically a part of the Council of Scientific and Industrial Research. It's not just a pure research institution, it is more on the industrial research and also takes up a lot of sponsored projects from sometimes from HAL and many times from the DRDO, ISRO. And we also have some research funded by the private industries. We have a lot of national test facilities which get regular projects from the sponsors. So if you see, almost all the expertise required for the civil aircraft are covered in this. You can see from the materials, it's not the development of materials, but characterization of the materials, the surface engineering, the structural design, aeroelastic aspects, test facilities I have already mentioned, and then airport instrumentation, the computational as well as the experimental aerodynamics, aerospace electronics, the composite materials. NL has been very heavily involved in the material testing and making the parts also. And wind energy is though not directly related to the civil aircraft, but it is an important part of activity at NL. And then the aerospace propulsion, electromagnetics and flight mechanics. So if you see the civil aircraft development at NL, the first seats were prior to 1990s when NL bought a ready-made kit, which I will show you in the next slide. And the first project was a two-seater trainer named Hansa. I think in HR slides we have seen the trainers for the military applications. This trainer is supposed to be the trainer for the civil pilots. And the unique feature at that time itself, which NL decided, was that it should be all composite in the early 90s itself. So we did a lot of work on the composites, on the testing, characterizations, manufacturing. And the great achievement in this project was that the Hansa 3, the version 3, was certified by the DGCA, and we had the civil certificate, and we could supply to the flying training organizations in India. So around the same time, once the Hansa project got a certification, NL started on design and development of the 14-seater commuter aircraft, SARS. So this was a push-up configuration, and this took about 10 to 12 years of development, and I will brief you on the some of the details. And in the backdrop of that, when the Indian industry was expanding in the airlines quite a lot, Mahindra's started an aerospace subsidiary in India. They wanted to collaborate within India for the design and development, and as per their survey, a 5-seater aircraft or a 4-seater aircraft will be a good fit to the market. Their ultimate aim was to market it all over the globe, and they had bought an Australian company which was specializing in simple aircraft and certifications. So that aircraft was called CNM5, C for CSIR, N for NL, M for Mahindra, and 5 is the number of seats in that, so that's the acronym. I'll give you some details on that also. And very recently, in 2019, one more relook was taken at the commuter aircraft, which is basically in FAR 23 category. It is not a transport category, but it is like unscheduled operations, chartered operations, which are covered in the commuter category. So we found that the configuration development had got some dead stops, which were making it difficult for us to progress on the aircraft. So a complete relook was taken with the prospective customers, the private airlines, and a lot of feedback, and then NL started the Stardust Mark II 90-seater development, where Mr. Jadhav was director of NL, and he pushed this project with the best capabilities. Also, in the same spirit, the Hansa aircraft, which was certified in 2000, was supplied to a few flying training organizations. NL was also operating it. Also, we found that it's avionics, and there are newer categories of engines available. So it was decided that Hansa will be also made into a new generation category without modifying the external geometry. Because for a trainer aircraft, its flying qualities, the safeties must be very acceptable, and Hansa was found to be very good in these two aspects. So therefore, the NMG of the aircraft was not at all changed, but the engine was more fuel efficient engine, much better avionics, and much upgraded electrical systems were incorporated, and Hansa NG also has got the DGCA certification very recently. So you see that Hansa aircraft is repeatedly getting certification, but on the other aircraft projects there are hold-ups. And those are the challenges which I will brief this community of aeronautical engineers. And also there were efforts on the 90-seater, 70-seater range in the year 2009, 2010, 2011. And a feasibility report was made by a very high level team, was submitted to government, but somehow it did not go forward. But after getting successes in the civil aircraft certification from DGCA, it was also decided in the same spirit that the regional transport aircraft, which is normally in the range of 50 to 90, will be restudied, the feasibility report will be refreshed. The government also gave in principle approval and sanctioned the money for the project definition phase. So NAL along with the HAL and ADA completed this project definition phase, and the report was submitted last year. And from there on, there are very frequent meetings and interactions at the Ministry of Civil Aviation, and we do hope that there are certain conditions imposed by the government, they would be fulfilled. I will touch upon these conditions in the later slides. So, as I said, the seats for NAL to take up the civil aircraft or civil aeronautics were shown with the bought-out kit. This bought-out kit was a long easy aircraft designed by Mr. Bert Rutan in the USA, and this is a very unconventional configuration. NAL bought it just for the purpose of setting up flight experiments, because prior to this there were no flight activities at NAL. It was a totally new activity for us. A new team was built up with the new young engineers and scientists who had inclination for the aircraft development. So this aircraft was flown for almost 8 to 10 years. No major snacks, and this aircraft and its kit, and then NAL also manufactured certain replica of these geometries to learn about composite manufacturing, which went into the Hansa aircraft. This was an ab initio trainer aircraft certified under the very light aircraft category. This very light aircraft category has an upper weight limit of 750 kg, and it was under the European certification rules. The DGCA had adopted the European certification rules, so it was applicable in India also. So if you see this specification here, the max takeoff weight is 750, and it is coming from the regulation itself. It is not set by the design. And the certification took place, and then NAL supplied about 10 aircraft to different aviation flying training organizations. You can see the list in the purple box there. Including IIT Kanpur also. They have a flight test experiments lab. What we found is that to manufacture this aircraft, all composite aircraft, we really could not find any single production partner which could take up the manufacturing, could take up the customer support, which could take up any overhauling which is covered by the airplane's repair manuals. The only possibilities NAL could get after multiple attempts was that there were companies who were ready to manufacture the major assemblies, for example fuselage. So NAL did whatever could be done by the private industry, and then rest of the work was done in-house by NAL, and almost 15 aircraft have been made. After a few years, what we found is that unless we upgrade, the FTOs will not continue to buy these aircraft. Even the aircraft which I have listed in the box, they were supplied through DGCA to these FTOs. They were not direct sellings, because direct selling in the aircraft business happens through the leasing industry. It is not from the aircraft OEM to the operators. So the in-between leasing industry was totally missing for this category of aircraft. So these are the aspects which were not very well known at the time of starting the project, but they are more of commercial nature. And an R&D organization like NAL may not be expected to know all this in advance. So we learned a few things over these 10 years. Just an interesting tidbit on the developmental quick bites, how the things change in the aircraft projects and what major changes are encountered. If you see this picture, this is an earlier version of the Hansa aircraft, in which you see the wing has got two kings. This was supposed to be very close to an elliptic wing, which the aerodynamics people consider to be nearly ideal lift distribution, the lowest drag possible. But what it led to is that it led to a very low aileron effectiveness, and since this is a trainer aircraft, it must have very good rolling capability, very good roll control must be there. So one of the things had to be removed, simplify, go away from the ideals of aerodynamics, but the airplane became much better, and it retained the roll control required as per the regulations. So on the aircraft manufacturing and production, we encountered several challenges. I have listed 3 of them, which were the really important ones. If you see here, since this was a composite aircraft, we did not have the repeatability manufacturing methods at that time. It was a hand layup method, which means it depends quite a lot on the skill of the workers. And workers cannot be there forever, same worker cannot be there forever. The workers will change, the weight will change by 15 kg or 20 kg either up or down, and by that much the fuel restrictions will start appearing on that prototype. So this was one of the challenges for which NAL made 2 prototypes just to see that the training of the workers takes place to a better extent. And to that extent we were able to manage for about 8 or 9 aircraft, but beyond that it became really tough to maintain the uniformity of the workers who do the layups. What was alternative? Alternative was to use the prepregs, which really was quite expensive those days. The machinery was very expensive, so it could not be employed in this project. So the second challenge I have already spoken on the production partner. The very, very important items in the production partner which NAL always desired but has never got is that the partner must also have a DGC approvals. It should have the DGC approval for production organization, it should have the approvals for maintenance organization. Of course, for maintenance organization, we find that people are interested, they are able to take and they do take. But on the production organization, we don't find any company in the private arena who has taken up for aircraft level. They do take up for part assemblies, sub assemblies, or for some of the part activities, not for the full. And then the after sales support and maintenance was also coupled to that, and the R&D organization in the name of CSR NAL just could not sustain the customer support for more than 10 years. Beyond 10 years, it became really tough for us to maintain the support personnel, to engage them, because we were basically and still to quite some extent a scientific organization as far as the nature goes. Now going to the next project, which was the CNM5, the 5-seater. As I said, this was a joint development right from the beginning of the project with the Mahindra Aerospace Limited. And the other technical matters are on the screen. This was also a low-speed aircraft, and Mahindra's intention was to market and certify this aircraft in foreign country and market it globally. And as I said before, they bought an Australian company, Gippsland Aero, who had 8-seaters and 10-seaters. They had experience with the certification of those aircraft in Australia, and therefore Mahindra outrightly bought, and that company became a subsidiary of Mahindra Aerospace. So the key points of the development, there will not be any cash transfer. The work share will be the monetary equivalent. The certification in India will be done by both parties, and it will be of course through a DGCA, and abroad by the Mahindra Aerospace. The design of the aircraft, either aerodynamic or structural aspects or any other controllability aspects, were fully by NAL, more or less. The manufacturing process is where the Mahindra Aerospace started contributing. They steered the design in such a way that the manufacturing is easier, less time consuming, because of the experience which the Australian company brought to it. So the weight was very much within the limits for the first prototype aircraft. We did not find the weight issues, which is a peculiar for many projects of the aircraft in the country and even abroad also. And the initial flight tests were also acceptable, but we did very little flight testing in this. In the next box, I'll show you what happened. So the Australian company bought by Mahindra, they started interacting with NAL, they started interacting with the DGCA. What they found is that the processes used in India for certification, for the manufacturing, clearance of the prototype, were complex as far as their thinking is concerned. They were used to a system in which the design organization has full authority from the certification. They will clear the aircraft, the design authority will clear the aircraft, not the certification. They will also do the flight test, not the certification. Certification will not involve until the design organization offers the aircraft for certification. The Mahindra's subsidiary was used to that kind of system, but in India what they find is that the certification wants to involve in each and every step. They would like to see all the reports, all technical reports, all test reports. So they really could not gel with that kind of method, and they decided that Mahindra should take the first prototype to Australia and take up the certification process in that country. The aircraft was taken to Australia, the documentation was shown to the Australian agency, but by the time the Australian company got into its own issues with their own aircraft and they became terribly busy in that, Mahindra did not want to put double teams. They said their teams will concentrate on the 10-seater aircraft of the Gippsland Aero, and then they will take up CNM5. But by the time the 10-seater got the certification, Mahindra had lost interest in any other project, and then the project had to be stopped. So if you see the last project, discontinued due to commercial reasons, agreement terminated. So this was the termination of the 5-seater, which from the beginning was very nicely done. The partner did not enter laterally, partner was there from the day one, all design done jointly, but somehow the later events did not allow us to progress with the 5-seater.
Vinitji, 3-4 minutes to cover your remaining important points.
Fine, sir. So I will just flash the slides on the Saras Mark 1, the commuter aircraft, which is in the FAR 25 to 23 category, which is a much different category compared to the very light aircraft category of the European agency. So this aircraft NAL made 2 prototypes. The second prototype had much higher engine power than the first one. And then NAL also flew a hybrid prototype called PT1N, which took the flight test results of the first 2 prototypes, and there were modifications. And the PT1N also went through almost 25 sorties, test flights. And the modifications, out of 7, the 6 modifications were successful, but one of them did not find the full 100% results. So by the time it was decided that NAL would not continue the pusher configuration. If you see this slide, this aircraft has got engines on the rear fuselage and the propellers behind the engines. So these are kind of a bit of unconventional configuration, but it has several advantages. The Saras Mark II, after interaction with the airlines, was changed to a conventional configuration. You can see that the engines are mounted on the wings, the tractor configuration, and the reasons for many other changes I have given in this slide. I will not explain because the session chair has already given me a time notice.
Session chair, yeah. We have to do it justice with the audience.
Yeah, sure.
In the next sessions.
Yeah. So in any case, the changes are quite, reasons are quite logical and matches with the demands of the configuration. Just like Mr. Jaikrishnan had shown what is indigenous and where we are still importing, we also have certain classification on all the yellows you see. There are a lot of imported content on the yellow boxes on the right side table. You can again see the autopilots, brake management system, propulsion, power plant, fuel system, avionics, and hydraulics for this category of aircraft. So this is where we find the challenges in buying the equipment also. So on the Mark 1, the achievements I have more or less briefed, and on the challenges, we found that the procurements of the qualified LRUs required for the commuter category became a challenge. Either the LRUs were available without the certification papers, which the certification agency will clear only for flight testing, they will not clear for the production. Or the LRUs are available for larger category of aircraft, which make the things very dicey. The real estate within the aircraft also will not be sufficient. And so, that's what I mentioned in the third bullet. LRUs had to be bought only with the performance test evidence, and the certification evidences we really could not get. And then after the project revisions, after 2 plan periods, those days we used to have the 5-year plans from the central government, we could not progress further because the obsolescence started kicking up and the developments within the country were not really progressing well.
My dear Puniji, sorry, but you have taken your full time. Okay. Another 2 minutes if you have anything important. In fact, the audience will be more interested in knowing your efforts on RDA.
Yeah,
because that is where the future lies.
Yes, so these are the slides. So this is the second round of studies of the RDA. The first round, as I said, were in 2009 to 2010 period. And in this round, we have again approached the government and showed them the justification with support from HAL and the Ministry of Civil Aviation. And the detailed project report already submitted, market studies were part of that, top level requirements are embedded in the detailed project report. And collaboration with major OEMs has been indicated, though collaboration has not been inked as contracts. And the structure of the special purpose vehicle which the government is repeatedly asking to make is given in the detailed project report. So this is just a demonstration of the RTA cockpit through which we are able to show the glass cockpit. Evaluation of the ergonomics, cockpits, symbologies, controls is taken up. So you see here a table on the right side. The aircraft OEMs with which the RTA teams have interacted are Embraer, Antonov, Irkut, Airbus, Boeing, and the Indonesian companies, and you see the conclusions what's happening. If you see, only Antonov and the ADR have some interest. Boeing and other companies are really not responding. And ADR has interest only in manufacturing setup. The design and development, more or less, except the Indonesian companies, they really do not want to collaborate because of their own proprietary reasons. So, so this project again may go for relook in the sense how to get over the requirements of having a partner in design. So I will skip this. And as I said before, for the RTA, the government has given an in-principle approval of nearly 6,000 crores, but it is subject to the condition of finding a design partner. And that effort is being done by all the parties, but till now we don't find that we are able to get a mutual agreement to go for contracts, and with that the project will move ahead. So in the next two slides, I will try to summarize the challenges and what we felt could be the possible solutions. So if you see, the challenge number one is to find anchor customers and committed orders. This has been mentioned by the other speakers also, and it is applicable, has been applicable to all our projects and most of our RTA, which is a much higher budget. And then design optimization and engagement with specialists. We really find that we have to go to global markets for these aspects. We cannot restrict to the Indian scenario because the civil aeronautics has not gone through that kind of development as much as you see in the military side. There are a lot of developments on the military side. So on the design and development investment, I will put up possible solutions after this table. So this phase is such that it takes a few years in which the partners will not be able to make money because this is not the production phase. This is only the design, development and certification phase. So there have to be mechanisms in which this phase can be endured by the partner, and how it has been done by the other developed countries, I will show you in the right side. Of course, C5 is related to the C4 and the C3. And production of small volumes again goes against the spirit of finding a partner. The partner is not enthusiastic because they find if we can assure only about 20 aircraft, they do not get the visibility how many years I can continue my line. Okay. So for the anchor customer committed orders, you see that the key is really the government funding. The key everywhere, all over the globe, you find that the key lies in the government funding, not by 5 or 8 years. You see in Europe, anywhere, any country in Europe, you see in America, you see in UK, the governments have funded the development of the civil aircraft to nearly 30 to 40 years continuously. And only after that, when these 3 or 4 issues are tackled, by the time this is enough time for the industry to develop, for the equipment to take place, qualification to take place in those countries, and then the private sector takes upon itself. Thereafter, it doesn't really need the funding to this extent, but this period has not happened in our country and it needs to happen sometime. Otherwise, we will keep getting stuck. We may do 50% work, we may do 60% work, and then there is a question mark. So all the issues of the return on investment, the gestation period, the design and development investment, everything can be tackled only in this way, and only in this way it has been done elsewhere, anywhere else. So there have to be financing arrangements. There may be some corporations which can control the budgets, which get visibility of the customers. So those mechanisms need to develop, otherwise it is going to be tough for India to develop the aircraft on its own. And there are other issues which help the design development is, for example, the tax exemptions. Almost 15% of the development budget goes back to the government in the form of taxes. So it comes here and then it goes back. So this can be very well controlled because nowadays many things are done through the government portals. And these controls can be implemented through the government portals, and then that much of project funding will have the relaxation. And then the skill development, we have also got feedback from the private companies that even they are finding it difficult to get the skilled workers for the aeronautics work. They are sending the workers to foreign countries, get the 30 or 40 people trained, and then in the next batches they will keep on training. But these 30 or 40 are not enough for any production company of any sizable requirement. So the skill development for the aeronautics technicians, supervisors is going to be a bottleneck whenever any private industry takes up, and there should be a mechanism. We have the skill development corporations, and the government has started very good mechanism and very widely spread mechanism. Now they are widening it actually through the apprenticeship program to the private industry also. So these contours may require to be embedded in those schemes. And then for the certification, as I briefed in the context of the CNM 5, there are challenges in our country in the certification procedures. The developed countries have become developed on the basis of simplifying these challenges and doing away with these challenges. Whosoever is giving the initial stake, the certification body, if they find that they are reasonably well manned, qualified people are available, they can do the audits, but then there has to be control handed over to the design organizations. Only then the civil aeronautics is going to really progress. So there is one more point which I would like to submit from the other side, and for that there is a mechanism called the subject matter experts or the design engineers representatives, which are the bridge between the design organization and the certification elsewhere in the globe. These people are like resolution professionals. They understand both sides of the game. They have the qualification, they have the experience, and they take care of the doubts of or the suspicions of the certification bodies, and they clear them. So the design organization gives some responsibility to these DERs, take them on the roll, and that's how the both sides can meet together and achieve to the certification of the aircraft. So these are our submissions, sir. And with that, complete my presentation. Thank you for listening patiently.
We are at 4:30 or 4:40 after hectic today's sessions, where from the morning we had very eminent speakers speaking about, and also very detailed interactions also. And today we are coming to the last session of the day, that is we are working on the defense manufacturing technologies.
I thank IMAE in providing this platform and privilege to share my thoughts on the development around the world regarding the evolution of state-of-art technologies in the maritime sector. Yeah. So now the important thing is that any evolution or any progress happens in the context of the prevailing environment. And the initial part of my presentation would give you that framework, which is leading to development of technologies in the maritime sector at a furious pace, followed by Indian scenarios and what are my recommendations. So let's look at the big picture first. And the big picture makes a distressing reading, because there are so many hotspots around the world. There are 45 armed conflicts going on in the Middle East and North Africa region. Asia is home to 19 non-international armed conflict, and then we have Europe, where we have one major international armed conflict going on, that is Russia and Ukraine. And in Mexico and Colombia there are 6 conflicts which are there. So the world is full of hotspots. While there is no world war, but it appears that world is at war. And another important thing which you will see over here, that maritime is playing a major role over here. As we know, globe is full of ocean, and any development in maritime has a major role in any battlefield. Now, when we come to the Indo-Pacific region, earlier the stated goal of India and its navy was that from the state of Hormuz to state of Malacca, that would be our area of interest. That is what used to be there. But from 2007, it emerged that not only the countries in Indian Ocean region, but even in the Pacific Ocean region, they are interconnected because of the reasons. Because we have a 67% population, 62% GDP in this particular region, and if you would see the center of gravity for economic development, which was there in Europe and then shifted to America, now has firmly shifted to the Indo-Pacific region. And when we look at trade, for India, 90% passes through Indian Ocean, and you could see what are the kind of submarine cables which interconnect the whole Indo-Pacific. And then we have the choke points over there. But when we look at what is happening in the Indo-Pacific region, you would see that there is an elephant in the room, and that is China. So territorial disputes are not settled, and hence there is a lot of unrest in this area. And all these headlines, they could give some kind of a reflection as to what is happening and what needs to be done as far as this region is concerned. And it is very important for India also to have a major say, and that's where the Quad, whatever is happening in that on that platform, that fits very well into what we want to do in this Indo-Pacific area. So again, this geopolitical context, evolution of maritime technologies, it is happening at a very fast pace. There was a time when it was all about numbers of men, numbers of fighter aircraft, number of warships, etc. But all of us are seeing what is happening in Israel and the way they are deploying technology, that technology, is changing the battlefield scenario in a major fashion. If you look at Israel as a small country, surrounded by so many, from their perspective, enemy countries, and they are outnumbered as far as numbers are concerned, but they are putting technology to a great use. And the best example, if I connect it to the topic which we have at hand, is what is happening with Ukraine. Now, recently, one of the spokesperson of Ukraine said that we have either disabled or destroyed 1/3 of Black Sea fleet of Russian Navy. They were outnumbered, outgunned, but what did they do? They used suicide drones, unmanned surface vessel to create this kind of a havoc. And I guess this reality is not lost on any of the decision maker in the world. And therefore we see that there is a large investment which is happening in uncrewed vessels, India included. But various countries, especially like USA, they have made great strides in this particular area. As per the James report, they are going to procure 89 to 143 of large uncrewed vessels by 2045. But there are very interesting developments which are happening. So one of the uncrewed underwater vessels by a Norwegian company, it traveled 1200 nautical miles at a depth sometimes touching 3,400 meters with a positional accuracy of 0.02%. And then there is another example down below, where USA is developing the CONOPS, the concept of operation of manned and unmanned teaming. And you could see that they deployed their 4 unmanned ships for 5 months in the Pacific, testing their concepts. This is a kind of evolution which is happening. And uncrewed platform, they are going to make an impact in the area of mine countermeasures also. We know it's a cat and mouse game as far as defense is concerned. You develop a weapon, then there is a countermeasure, then another weapon, then another countermeasure. And here the mines are becoming now, they're getting technologically improvised. They're becoming smart. So how do you try to neutralize them by not putting any human in danger? And that is where this concept of using uncrewed vessels for mine countermeasures is coming into place. Keeping these contexts in mind, most of the countries, they are focused on making their oceans transparent. And that is the objective of underwater domain awareness. It is very well known that mankind has not fully mapped its seabed. And this unmanned domain awareness becomes very, very critical for our country also, because we know how Chinese ships are coming in our close proximity, how are they mapping our seabed, and what we need to do in this particular domain. And this is also undergoing a lot of improvement and a lot of progress. Now this underwater domain awareness, it also feeds into anti-submarine warfare, where other non-acoustic technologies to monitor and sense submarine activities are being developed. Let me just share a few examples. The laser devices are being created which generate an energized beam of light of a single color or frequency, and as I understand, green and blue beams can penetrate water with relative ease, and such devices may help identify the presence of a submarine. Then there is a technology of identifying the wave detection with the help of satellites. And satellites might see subtle undersea disturbances caused by submarines, watch wave patterns on or beneath the sea surface, or detect subtle variations in ocean temperature. Another interesting technology is the magnetic anomaly detection. MAD is a technique that detects anomalies in the Earth's magnetic field caused by nearby magnetic objects. The range varies, but they will generally detect anomalies at a depth of approximately 1200 meters. And I understand that Chinese researchers have recently tested their new submarine detector, which can detect a submarine 20 kilometers away. Not only in this area, in the recent year, naval forces worldwide have dealt with the spread of challenging threats from supersonic, high diving, or low level, highly maneuverable anti-ship cruise missiles, swarms, etc. And in addition to even more demanding hypersonic weapon system in congested and contested little water. This has required the industry and naval operators to move towards inner layer defense system with longer range and network capabilities alongside innovative solutions. And these are some of the examples which various countries are developing. All of us know that as far as artificial intelligence is concerned, they are having very, very disruptive impact. The database decision making is taking prominence, and a lot of solutions or out of the box technologies are coming through. And some of the examples like killer robots, and we have autonomous weapon systems which are becoming prevalent. A recent study of procurement data by the Center for Security and Emerging Technology at Georgetown University found that America and China are devoting comparable level of attention to a similar suite of AI application, and India still has a long way to go. Then we move to the next generation propulsion system. Now they are designed to be more efficient, reliable, environmentally friendly than previous system, and a lot of focus is going on developing zero emissions, improving electrical efficiencies and vessel range. Composite propellers, revolutionary propeller hubs, vortex cavitation, eliminating boss caps are some of the cutting edge research which are underway as far as this area is concerned. Again, this background, let's see what is there in India. And when sometimes we discuss in our company and we look at these technologies and we believe that we must aspire to develop some mastery. And we say, put our hand to the heart and say where India stands. and normally it comes out, we are maybe 3 or 4 out of 10. Now, we believe, this is our belief, that as we see in USA, we see in Europe, and that kind of model as a country we are following, that private sector, because of a lot of agility, lot of independence, can play a major part in not only doing a catch-up but also leapfrogging, in some of the technological area. But what are the challenges, and I will come to that in a minute. But what you see over here, that lot of focus keeps going to MSME and startups, and there is no doubt that the focus should go there because they develop a lot of employment. But when we look at that, there is a lot of talk which is happening on involving the private sector and the big sector, but their participation in the defense is static. It's not going up dramatically. These numbers are 24% only for a few months as far as this thing is concerned. And while we are saying that there is a defense exports is going up, but still, we have a long way to go, even though we are making a lot of strides in this. And if we see over here that government is trying to push for a lot of development, innovation through Make 1, Make 2 program, Make 3. Number of programs have been announced, but they're like, I know about Make 1, there's only one program which has gone through out of 44. And that also tells the story that, how long we have to go in ensuring the implementation of all these policies. But the interesting thing is on this chart. This I recently picked up from a business standard report where Mr. Godrej spoke about, what is the challenge as far as Indian privates or Indian industry, why are they not investing in the R&D. So there was a talk by the previous speaker in the earlier session that we invest 0.3% of GDP and we must take it to 2% of GDP. And I'll come to that. But the interesting thing is Indian industry has no presence of the 6 industries in the world where the maximum investment in R&D happens. And that includes technology hardware, that includes electronics, general industrial and industrial engineering. And where Indian firms are present, this last column is where Indian firms are present, and you could see, there is a pharmaceutical and biotechnology where you see 10 Indian firms, right? But they are also not investing in there in a major fashion. And one very interesting fact which is there is that our 10 most profitable non-financial firms make an average profit of 16% of sales and invest 2% of profit in R&D. And if you remember our colleague from HAL, he said that we are some 70,000 crore and we just invest 2%, and he was talking about more should be invested. While for top 4 countries of the world, for their top 10 non-financial companies, the profit number varies from 9 to 25% and they invest 29 to 55% of their profit in R&D. So, question is why Indian companies do not invest in R&D? And one of the study which was done is about this. This is, I picked up from the Power of Creative Destruction. What it says is there is a technology frontier curve. If the companies are far away from this technology frontier curves, they will not dare to invest because they feel that it is a long way to go. वो करके कुछ फायदा नहीं होने वाला है. We are already so far behind that it does not make any sense. And most of Indian companies are somewhere here. That is one issue. The second issue is if Indian industry do lot of exports, right, and you fight with the global competition, then there will be urge to invest in R&D. But what we have seen, and another interesting number, in 2012-13 financial year, 18% of sales in the manufacturing sector was for exports. And this number in 2022-23 has reduced to 7%, and as per CMI forecast, this will reduce even this year also. That means from the manufacturing sector in India, the percentage of exports is coming down. And why is that happening? Because there is a large consumer base, India is a growing market, so we believe the government should provide us protection, and we have a protected market over here, and why to invest in R&D. So this is a vicious cycle in which we seem to have gone in. And we need to see how do we break. And another interesting thing which government needs to look at, this is a competitive index. I picked up from the IMD World Competitive Index Yearbooks 2024, and you would see that India is more or less static, is not moving, the needle is not moving very fast. So while there are a lot of policy announcements which are happening, but their implementation on the ground perhaps is taking more time. So because now we are not getting conducive environment, for example, our logistic cost is very high. Prime Minister office is trying to do through that project Gati, that how could we bring down the logistic cost. The cost of finance is very high. Then we have a question of the skill set of our people. There's so many factors. So our competitive index is also not going up. So hence this is a kind of a vicious cycle. And since if this is all applicable about the general industry, it's the same situation in defense industry also. And this report which I picked up from World Bank data, it says that we have a lower R&D intensity. And these were some of the reasons which I just spoke about it. While Dr. Kamath in one of the recent interview, he said that cutting edge, that was mostly with the DPSUs and I think DRDO, that they get awarded due to aversion to risk and intolerance of failure. But this kind of thing does not happen in the private sector. Private sector is ready to take risk if they find that there is a long-term merit and then there is a long-term return which they may get out of those investments. So what could we do to perhaps break out of this logjam? So one of the key thing is, yes, industry has to participate and especially private sector should come into this in a major fashion. But the important thing could also be how the ecosystem in India and especially I would say the DRDO could nudge the Indian firms to go toward the technology frontiers. So there are few ways which I thought could help. So one was the strategic partnership. So this whole thing came out that they already all our defense public sector units are well entrenched. They are having a very large order book, and we must try to bring in the private sector also. In the morning plenary session, Elon Musk spoke, the reference was made to Elon Musk, and how as a startup he broke into a different technology, space technology, and came out with reusable rockets. So there's a lot of innovation which can happen if that animal spirit is unleashed. And that's why we have suggested that the strategic partnership should have only private sector, give them some leeway, create some space for them so that they can take the R&D as well as the industry further. Then we keep getting no-why from DRDO, and we thank you as a L&T. We thank DRDO the way we are in defense. It is because of the DRDO. We started our journey with the integrated design development program, I think from this campus only. But now that we have graduated, we have come a long way. It would really help if, in addition to know-why, the industry is also given the know-how. And we create those mechanisms of passing the know-how. It should not be, let's say, held, let it grow further. I give an example. We are doing AIP with SIR only, air independent propulsion. Now there is a requirement of doing, or changing the whole configuration to the P-76 submarine. And it may be, for some of the Scorpion submarines which are abroad with the other countries. But on our own, even today, we are not able to do that kind of a change because we have a know-how to put this whole system together, but we do not have a know-why to reconfigure or repurpose it for a different application. That is the thing missing, and that's where we feel constrained to go out and sell this kind of projects. And there are many more such examples which I could share. Then, small nudge which could be given and which we have been requesting the government that to encourage private industry to undertake R&D, to move the needle from that 0.3% or 0.6% to 2%, if the tax rebate, so whatever money is being invested in R&D, like today at L&T we invest some 7% of our revenues into R&D, into the design. I'm not saying the TRL of 1, 2, 3, but I would say from TRL 4 to TRL 8. So that is the kind of technology readiness level in which we invest. Now, yeah, just 2 slides. So if this tax rebate could be given, reinstated, it would help us to push more money into R&D. And what we are also requesting that all expenses relating to NCNC, DRDO programs, etc., they should be included in this kind of a tax rebate. And there was a discussion about 25% R&D budget to industry, academia and startup. So some process should be promulgated by which we can make it happen. Then another important thing is increase MOD funding, make 1 to 90%, right? Because this is high risk project, and the failure rates are very, very high. So if this could be supported, it will go a long way. Give custody of IPR to the development agency. Then select development agency based on technology and cost, both using the both. This is a quality term cost-based system, and it has been promulgated by Ministry of Finance. Make more use of it and avoid high-tech and expensive program under Make 2. There has been a lot of discussion about infrastructure and testing facility. We know DRDO has taken that initiative to put all their testing facilities on the web. But what we are basically requesting that the transparency into when those kind of slots are available. Could we have a reliability that I want to do the testing when it would be made available? So if that would be made simpler, it would help. And incentivize the investment in defense test. Now there is a Section 8 company, no profit basis, no private sector will come in. So there has to be some incentive for private sector to invest in, and extend user support during testing. That means provide ammunition as FIM, make available testing range and user asset. More we can facilitate it, better it is, and faster we can do the development. So that's all from my side. Thank you.